Dokie. Um, so far I've been talking about exponents and been telling you that it's going to be like a game. All you need to know are the rules of the game, and today I'm going to give you the rules. So check it out. If you go on Neo, our assignment is right here, notes, summary of exponents, and I'm going to give you the key to the game, okay? So this is what it looks like. I already have it on Neo, so go ahead and get it, okay? Upload it to Neo. So I've already given you notes on all three of these different types of ways of working with the exponents, multiplying exponents, power of powers, and dividing. So here, there's going to be multiplying right here. So I'm actually going to label it multiplying, multiplying, power of powers. The last one is dividing. Okay, so these are all things that you already know. Okay, I want you to look at these, and we're going to start looking at what is the rule, or what is one way that we can quickly, right, identify how many exponents we need. So here, we're going to be multiplying x to the fourth times x to the 12th. So here you go. X to the, oh no, I gotta erase all that. Sorry guys, because I'm undoing all this. Undo, 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 undo. Okay, so here it is. X to the fourth. That means that x is going to be multiplied by itself 4 times. X to the fourth times x to the 12th. So there's 4 here and 12 here. Now the question is, how many x's are there total? Okay, so simplified. How can we simplify this easily? We notice that we have the same base x, okay, and the exponents. What are we going to do to those? You can always expand. That's always an option. But here I want you to notice that we have x to the fourth plus x to the 12th, because there are 4 here and then 12 in this next one. So that means that there's going to be a total of 16. Okay, hopefully that makes sense right there. We are going to add the exponents. Okay, x to the fourth and x to the 12th, there's a total of 4 plus 12, which is 16. So here's another problem. I would never want you to write x to the 25th and x to the 42nd, 42. Like, that's a lot of time. That's a waste of time. So here I'm going to just say x dot 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 x, and that's going to represent 25, okay? Times x to the 42, just like I did about 25. I'm going to say the same about 42. Now, I want you to see that we have a total of 25 and 42. So altogether, how many x's do we have? Okay? And I want you to know that we are going to take x to the 25th plus 42. There's going to be a total of x to the 67th. Okay? So right here, what are we doing? We are adding the exponents when we're multiplying. I want you to see that we are multiplying right here. Look at this. This is a multiplication sign. We're multiplying, and the bases are the same. When that's the case, we can add the exponents. Okay, so that's kind of the rule that I've been talking about. Learning the game, this is the rule. Okay, so here's my final example for multiplying exponents. Okay, x to the k. Now, k, that's a variable, right? You don't know exactly what number that is. So here, I'm just going to write x a couple times and say, all right, here's k, whatever number that is. That can be 1, that can be 3, that can be 20, that can be 50, whatever it is, k. Okay, it's a variable. We don't know what it is. X to the k, and here's x to the m, whatever number that is. The m is a variable, so it's just saying a number, okay? Well, here's a way to generalize the rule, okay? We can take x, and we are going to add the 2 exponents, k and m. Whatever those numbers are, we're going to add them together, and we're going to get that. X to the k plus m. K and m, they're variables. Okay, so what we're doing here is still we are adding the variables. Hopefully that makes sense to you. This is abstract. The numbers are like not concrete. They're variables. So It is a little bit tricky, but I want you to try to follow along, okay? So that's everything for multiplying exponents. Now, power of powers, we're going to have a different rule. Here, we have x to the fifth, all raised to the fourth power. So that means that we're going to have x to the fifth 4 times. So 1, 2, 3, 4. 4 groups of x to the fifth. So there's 5 here. Oh, here's 5, here's 5, here's 5, and here's 5. So we're wondering how many x's are there total? Like I said, you could always expand this, but now I'm trying to teach you, is there a way to simplify this in a quick way, right? So we can take x to the fifth all raised to the fourth power and say that it's going to be 4 groups of 5. What's another way of saying 4 groups of 5? We can multiply 4 times 5, and that's going to be x to the 20th. Right here, if we sit here and count, there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, and 20. Okay? So x to the 20th. What we can do is when we have power of powers, we can multiply the exponents. All right? Here's our next example. X to the fourth all raised to the third power. So we have x to the fourth right here, and we're going to have 3 groups of 4. So we need 1, 2, 3 groups of 4. Now, we know that this is 4, this is 8, this is 12. So there's a total of 12. And what we're doing here is we can say x, and we're going to multiply 3 times 4, which is x to the 12th. We are multiplying our exponents when we have power of power. So this is a second rule that I'm giving you guys, okay? Multiply the exponents. Last one. X to the c all raised to the n power. Now, x to the c, just like we did earlier, it's a variable, so it's whatever number that variable is, okay? So here's c. This is going to represent c. Now we need n groups. So here's another one, here's another one. I don't know exactly what n is, so I'm going to write dot, 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 right? And there's going to be n groups, number of groups. So there's c, that's 1 group, 2 group, 3 group, dot, dot, dot. We don't know. Whatever n is, right, that's how many groups there are going to be. And we know that we can now multiply the exponents. So we're going to have x to the c times n, whatever c is and whatever n is. And we have x to c times n. What we're doing here is we're multiplying, okay? The last. So power of powers, multiplying. Those are things we did while we were in school. Okay, here's another one, just dividing. We just did this very recently. Okay, so here we have x to the 15th. I went ahead and wrote all 15 out, divided by x to the third. Okay, and what we can do here is we can create zeros. So here goes 1, 2, 3 zeros, and that leaves us with how many x's on top? Well, hopefully you're starting to see that there's a quick way here. There's a rule. Okay, we have 15 on top and 3 on the bottom. We have a total of 3 ones. You can see that right here. Okay, so what we're going to do here is we're going to take 15 minus 3, because there's 15 on top, and we created 3 ones. So whatever's left here is going to be 15 minus 3, and that's going to be x to the 12th. Okay, like I said, you can always expand it, but it'd be nice if we had a rule, and here it is. So what we're doing is we're subtracting the exponents when we're dividing with the same base. Okay, so here, x to the 24th, that's a lot. I don't want to write it all, so here I'm just going to say that's 24. Okay, divided by x to the 30th. There's 30 down there. Okay, and we know that we can create ones here. And I'm going to go ahead and draw all these ones. The dot, dot, dots are representing. So there's a total of 24 ones we can create. Okay, so I'm going to go over here. I'm going to show you that this is going to equal 1 over x to the 6th. There's going to be 1, 2, 3, 4, 5, 6 left. Ooh, I think I made a mistake. 1, 2, 3, 4, 5, 6, 7. Yep, one of them shouldn't be there. My bad. Okay, I'll erase it later at the end. So x, and we're going to do 24 minus 30, which gets us -6. And when you haven't learned about negative exponents, but x to the -6 is going to be the same thing as 1 over x to the 6th. Okay? So what are we doing here? The rule is to subtract the exponents. When we're dividing and the bases are the same, you can subtract the exponents. Here's our last one. X to the d, whatever that is. We don't know how many there are for d, so here's just an abstract amount. How many d is, there it is. And all divided by x to the f. That's the problem, okay? What we're going to do is we're going to create ones with whatever you can. And we have x to the d minus f. What we're doing here is we're subtracting the exponents. Hopefully that's making sense to you. Okay, so I'm going to go ahead, like I said, go ahead and erase one of these because I made a mistake earlier. So here are some practice problems I'd like you to do. X to the third all raised to the 6th power. So here I'm going to do 1, 2, 3, and I'm going to multiply that 6 times. JK, I'm going to use my rules. My base is the same, and if I have power of powers, I'm going to go up here, power of powers. What am I going to do? I'm going to multiply the exponents. So right here, there's going to be 3, 1, 2, 3, and there's going to be 6 groups of that. So what is 3 times 6? That is 18. Okay. Here, this one's dividing. So let's go up here. Let's find a dividing. And what do? We subtract the exponents. So I'm going to take 20 and subtract 4. This is x to the 16th. Hopefully this is a lot easier for you. Okay. And here we're multiplying. Let's go find our multiplying. Okay. And what do when we multiply? We add the exponents. So I'm going to add x to 5 plus 8, which is 13. Okay. That's it. Okay, so go ahead and open up your homework. Here are some practice problems. Use your notes. I'd highly recommend you to split your notability, to have your notes open. Okay, and right here, explain the difference between these two. Well, they're different problems. Explain how they're different. Same thing with this one. Explain the difference between the next two and how their expanded forms differ. And then here, simplify. I want you to use the rules that you know, okay, and solve. If you need to expand it, you're more than welcome to. You're always allowed to expand, but I just gave you the rules to the game. Hopefully it's something that you feel comfortable with, all right? Okay, so go ahead and give this a shot, and go ahead and turn it in by its due date. See ya.